Okay, we will talk about the effects of disease state in drug interaction and drug metabolism in the liver, and we will have some assumptions. Let's go through them one by one to make it easier for you to understand what I'm talking about. One, we will assume that the total clearance is only hepatic clearance. So if we are going back to what is the total clearance is renal plus hepatic if we are talking about non-renal. So it's renal plus hepatic. Then if we consider that it's not there, so only we are talking about hepatic clearance. So one of our assumptions that is slowly affected by total clearance, slowly affected by hepatic clearance. Okay. Another thing we are talking about that the steady state free drug concentration is the concentration that would cause the effect of the pharmacological effect or pharmacological response. When we want to determine if there is any clinical implication of whatever is happening in the metabolism, we need to know the route of administration, because it's affected the end whatever is happening. We need to know the extraction ratio, if it's high, if it's low, if it's intermediate, and the presence of protein binding and what kind of protein binding that would be affected. All of those would affect the end or the consequences of any effect that would happen caused by disease or caused by drug or drug food interaction. Okay. If we go back of whatever we mentioned about the hepatic clearance, we mentioned that it's equal the flow multiplied to the extraction ratio and the presence of protein binding. So we need to take into consideration the free fraction of the drug. Okay, if you remember when we talked about IV infusion, okay, so concentration versus time, this was our profile, and we have at steady state concentration. If you remember that the steady state concentration equals R, which is the infusion rate over total clearance, which is R over total clearance, and R was equal to K naught because we are talking about zero order reaction or zero order kinetic process, okay, for the infusion. Okay, so if we are only talking about under the condition that the total clearance equals the hepatic clearance only, then the steady state concentration would be equal R over hepatic clearance or K naught over hepatic clearance. Okay, this is the total concentration, whatever that we are measuring. The total concentration is R over hepatic clearance. If we want the free or unbound concentration, steady state concentration, we need to multiply the total with the fraction unbound or the free drug. So it would be the fraction, the free fraction of the drug, or the fraction of the free drug or the unbound drug multiplied to the total concentration. In terms of R or K naught, it's the same because as we mentioned, R equal K naught. Okay, so let's start with the example that we have, the effect of the drug, okay, in this case ciprofloxacin, which is enzyme inhibitor, on the pharmacological response of theophylline. Okay, so we are talking about theophylline and we are talking about drug-drug interaction or drug effect. Okay, so let's read the case or read the information that you need to know. Theophylline is metabolized by CYP1A2 with low extraction ratio. So the extraction ratio is low and low protein binding. Given theophylline as a constant infusion, so the drug is given by infusion, produces steady state concentration of 15 milligram per liter, and then it's giving you an information about the therapeutic range. Assuming that the ciprofloxacin reduces the intrinsic clearance by 30%, so the effect would be an intrinsic clearance, okay? So it reduces the intrinsic clearance by 30%. What would be the effect of giving ciprofloxacin on the pharmacological response of theophylline? Just notice that we are talking about pharmacological response in which we mentioned that this would be slowly affected by the free fraction of the drug. So if you go about the details step by step, if we are talking about low extraction ratio drug, then the hepatic clearance is equal the fraction free multiplied to the intrinsic clearance because it's low extraction ratio drug. For the infusion, this would be our total, and the total, it depends on whatever that we have here. We substitute it in the hepatic clearance, okay? Again, this is total. The free concentration would be the same, but multiplied with the unbound fraction of the drug, which would be equal to this. Then the effect of the ciprofloxacin, which decreases the intrinsic clearance, and the total concentration, if this is decreases, it means, and this is for the free also concentration, if this is decreases, what would be the effect of each one of them? You can find that by, one second. The first thing that you need to do is just to write the total and the free concentration. And we know, according to whatever that we have, if this goes with this, then this is our final for the free, and this is our final for the total. The effect, according to the question, that the ciprofloxacin would decrease for the intrinsic clearance. So accordingly, this would be decreased by 30%. So accordingly, this would increase. This would be decreased by 30%. So this would be increased by 30%. Accordingly, according to the information that you have, one, the total measured concentration is expected to increase by 30%. In addition to, the therapeutic effect or pharmacological effect is expected also to be increased. And this is what I'm telling you here. We should anticipate a significant side effect at the higher free steady state concentration of theophylline, and that's why we need to do some consideration or correction of the dose or whatever dosing rate, as we are talking about infusion, because it would increase by 30%. Okay? If we are talking about the effect of decrease in the protein binding on phenytoin due to renal failure. So we are talking about disease or disorder in this case, and the effect of this disease is on protein binding. So whatever is happening here, phenytoin is mainly metabolized by CYP to C9 and to C10 with high protein binding plasma of 90% and low hepatic extraction ratio. So one thing that we have low extraction ratio and we have high protein binding. Okay, so and it's metabolized by 2C9. Giving phenytoin as IV infusion resulted in a steady state concentration of 50 milligram per liter. During the treatment, the patient have renal failure. So here the effect of the disorder started here. So decrease the bound, the percentage bound in the plasma from 90 to 80. So that the binding decrease, okay, from 90 to 80, which means the fraction and bound is what is increased. Okay, what is the impact on the phenytoin pharmacological response, assuming that the free drug concentration is what controls the pharmacological response? Same idea here, and let's do the slide. Here we have in the question we have low extraction ratio. Then again the effect of the we have low extraction ratio, and then the hepatic clearance would be equal to the intrinsic clearance, and we are taking the protein binding into consideration. The as we are talking about infusion, then the total concentration would be equal R over hepatic. Then the steady state total concentration would be equal to this. And again, we just substitute hepatic clearance with the intrinsic clearance because it's low extraction ratio drug. for the free drug, we take it, multiply to the fraction free, and then we have this, okay? And again, this will goes up with this. So if, according to the question, the fraction of the unbound drug increases, then the effect would be on the total expected to decrease the fraction, the steady state concentration total, but would have no effect on the free because it's only having the R over intrinsic clearance with no effect of the fraction unbound, which means that accordingly you are expecting the total concentration you measure of the drug, the total concentration to be less than you anticipated because of the effect of the renal failure, but still even the concentration measured is less, the response or pharmacological action is not affected. And this is what I'm showing you or telling you here, that we have no significant effect change in the patient pharmacological response despite the decrease in the steady state total concentration that we are measuring, okay? For the effect of the increased and protein binding due to myocardial infarction, again, we are having disease and the effect of the disease on the protein binding. Example in different example to show you a different effect. Lidocaine is metabolized by hepatic CYP1A2 with high extraction ratio drug. So we have high extraction ratio drug and highly bound to plasma, mainly to alpha-1 acid glycoprotein, was given lidocaine was given for a life-threatening ventricular arrhythmia as constant IV infusion to give a concentration of 4 milligram per liter. The patient have MI and on the next day this disease increases the plasma level of the protein. So we have protein increased as concentration, the plasma level of the protein increased, which means this effect would decrease the fraction of the free drug. Okay, so accordingly, if we are talking about, again, the hepatic, it will be related to the flow only, or almost the hepatic flow, because it's high with the drug with high intrinsic clearance. So if we are writing the total, would be R over hepatic. If we are writing the free, would be the fraction free multiplied to the total. So the fraction multiplied to R over the flow of the hepatic. Then if we ask ourselves the effect of increases in the protein binding, increases in the protein level. So we have increases in protein level. So this causes the fraction unbound or the free of the drug to be decreased. So we will not have any effect here because the fraction unbound is not there in the equation. But if this is decreases, this would cause increase in the concentration of the expected concentration of the free drug. So accordingly, what would happen that what you assume that you will see that even the total concentration of lidocaine that is not changing, that the response despite similar steady state, measured steady state, would be reduced. So accordingly, if the concentration, I have this wrong, please correct it at your side. If this is decreased, this would be decreased. Sorry for this mistake. Okay, so despite the fact that the total concentration that you measure won't be different, but you are expecting a decrease in the total steady state concentration that you are having, which means a decrease in the effect of the drug that you are taking. And why is that? Because we have increase in the level of the protein, so the fraction unbound or the free would be less. Okay,